Hello and welcome to this demonstration of some new features in Drogue device around bootloading and firmware updates. So today we're going to use this device, which is an Adafruit Feather with an nRF52 chip, so it can do Bluetooth. You can see I have attached a debug probe. I have also attached a USB cable for power and also the serial pins on the back here. Today we're going to demonstrate 3 different approaches to updating the firmware of this device. So we have an application, and this is a demo application that you can run yourself. Running Drogue device. The application itself is only blinking a LED, as you can see, but it's also demonstrating the use of firmware update capability and using a bootloader. We have different actors to enable this. First we have a DFU actor, which is writing to the flash of the device. The settings of where it should write is defined by the bootloader library that we're using. That's an embassy library. And then we have different actors for doing the firmware updates to demonstrate. So one is the serial, using the serial cable. We also have one using the USB port, so you can actually just have the USB connected and you don't need a debug probe really. And then we also have a BLE GAT service that we can use as well. And then we have a blinker task, which just blinks the LED. So we can adjust this, demonstrating the different versions. So first we're gonna flash the initial version. So we just use debug probe for that. And it's running. So we can now look at the DFU tool that we're going to use. drgdfu. So the drgdfu tool can generate a metadata file from a binary firmware file. This is used by the tool later on to upload the firmware to a device. And when you do upload, you can select the 2 different modes. One is the BLE GAT mode and also a serial mode. And the serial mode you can use with both the USB and the UART. First we need to update our application, and we can adjust the blink interval to 3 seconds, and then we can also build a version with a new revision. So the application will encode its current version within the binary itself, so we can use that in the update protocol to check that the device actually got updated. So with that, let's build a new version of it, and then we can use the drgdfu tool to generate a new metadata file for this binary, and it will just print it to the console, so we can add it like this, and then we can choose which approach we want to use for updating the device itself. So in this case, let's start with the serial approach. So we'll use the port of the USB to serial adapter that I have attached to my PC, and we want to use this metadata file that we generated. So this will transfer the metadata to the device, and using a frame protocol that we have defined for the serial. So now you can see the LED stop blinking. Now the bootloader is swapping the different firmware versions, which takes about 10 to 20 seconds. So we'll need to wait a little bit to see that, and then once it's done, the tool will check if it's back and ready, and it reports being up again. And now we can see the blink interval has changed, so it's spending a lot more time blinking, longer time blinking. And then we can generate a new version, adjusting the blink interval to a quicker interval, let's say just 100 milliseconds, and then we can generate a new file, and and then we can generate another update. So we can say update. Okay. So this time, let's try to use the USB approach to update, and then it should be attached to a different device. One thing to note about USB is that when it's resetting in, the device will disappear from the OS, so it won't actually be able to verify that the device has been updated, so you get this error, and then we'll need to await until the device comes online again in order to instruct it that it actually did a successful firmware swap. Oh, you can see it's blinking a lot more frequently. We run this again, and now it reports the new version. So that's the two different approaches we've seen so far. The serial first, and then the USB. Now we're going to see how to do it using Bluetooth. So no serial and no wires apart from needing for the power. And then we'll do another modification. Blink. Let's change this back to 500 milliseconds, and then we produce another version. And we generate a new metadata file, and we can do the update. So this time we'll use the BLE GAT mode. Device, we need to have the MAC address of the device. So I'm going to cheat a bit and get that from somewhere else. Device. We'll copy paste that into our terminal there, and then we're going to use a file. So this approach is a bit slower than the others because Bluetooth is slower. In this example, we're using a payload size of I think it's 128 bytes, but it's reporting the progress as it's being written. And then you can also notice that we have a cloud mode, which is a feature we're working on in order to have the tool just connect to the Drogue Cloud APIs and automatically getting the new versions, as we've seen in a previous demo, but using the Drogue Cloud APIs and no additional service from the device perspective. And it's close to finish. The binaries, I think, is 29K, so let's see. Oh, it's about 40K, yeah. And the nice thing is you can use this with any NRF device. We also plan to have a BLE mesh mode for this. So now you can see it stopped blinking, and we're awaiting it to turn up again. Swapping the images. So the protocol that the DRG tool uses is the same whether you're using a file or you're using the cloud. So there you can see it started blinking slower again, and it's updated to the latest version. So that's just a demonstration of the DRG tool. You can get this from our Drogue IoT GitHub repositories, and it should work out of the box with the Adafruit feather examples. So happy hacking!